Welcome back everyone. In this video we're going to be talking about how we can interpret what a definite integral actually means. And when you get to Calculus 2 you're going to spend so much time computing integrals it's very easy to forget what this thing actually means. And it's not just the area under a curve, it has a very practical interpretation as well. And as an example, first remember that if you have a function that represents the position of an object over time, then its derivative would represent the velocity of the object over time. We spent a lot of time doing stuff with that this entire term, and now we're going back the other direction. If we have a function that represents the velocity of an object, then taking the definite integral from one time a to another time b of this velocity function, that would represent the change in position from a to b. And so with derivatives, we start with position and get velocity, whereas with definite integrals, if we start with velocity, we get a change in position. Now keep in mind that the definite integral does not give you a new function. The answer to a definite integral is a number, and so this is not a new function. This specifically represents the change in position, not the entire position function. Now let's talk through an example that's a little bit more concrete. And let's let v of t represent the velocity in miles per hour of a car driving on a highway t hours after starting the trip. And what we're given here is the velocity function. This is a rate of change in miles per hour. And let's say that I were to take the definite integral from 1 to 3 of this velocity function, and maybe I got the answer 50. The interpretation for this is that 3 hours after starting the trip, the car is 50 miles ahead of where it was 1 hour after starting the trip. So this definite integral represents the change in position from t equals 1 to t equals 3. That's where the 1 and 3 hours comes from. And that change in position is 50 miles. Not just 50 miles, 50 miles ahead of where it was. If this was negative 50, which is perfectly possible, that would imply that the car had moved 50 miles back from where it started. Now, there's a little bit of nuance here in that this definite integral does not imply that the car drove 50 miles. The car could have driven 150 miles forward and then 100 miles back. And this 50 only represents the change in position from 1 hour to 3 hours. We have no idea what happened in the middle there. We just know that after that time period, the car is 50 miles ahead of where it started that time period. Let's do another example that's not about a car driving, because I think we do enough of those. And let's say that we have a function r of t that represents the rate in liters per hour at which water flows into a reservoir t hours after midnight. And this is still definitely a rate of change, with that rate being liters per hour. And so when I integrate this, whatever answer I get should have a unit of liters. Let's say we took the integral from 7 to 10 of this function r of t, and perhaps that gives me an answer of 1,000. This would imply that from 7 a.m. to 10 a.m., the amount of water in the reservoir increased by 1,000 liters. And the 7 a.m. and 10 a.m. comes from the bounds of 7 and 10, and the fact that t represents t hours after midnight. And notice that my answer here is an amount of water in liters. And so we started with a rate in liters per hour, and we got an amount of water in liters. Now let's do one last example. And for this example, let's say that the rate at which the world's oil is consumed in billions of barrels per year is given by the function f of t, where t is in years and t equals 0 is the start of 2004. So once again, we're given a rate of change, with the units there being billions of barrels per year. And let's say I wanted to write a definite integral that represented the total quantity of oil consumed from the start of 2004 to the start of 2009. What integral would I have to write to represent that quantity? And it's tempting to make your bounds 2004 and 2009, but keep in mind what the variable t represents. T does not represent the year, it represents the years since the start of 2004. And so my bounds are not 2004 and 2009, they're actually 0 and 5, because that's the number of years since the start of 2004. And then from there, we're just integrating this rate, which is f of t, and don't forget about the dt, that's always an important part of every integral. And if I were to integrate this, if I knew what the function actually was, the units of this answer would be billions of barrels. We started with a rate that was billions of barrels per year, and integrating that gives me just billions of barrels. And so the theme here is that if you're starting with a rate of change that being some quantity is changing over time or with respect to some other variable. Integrating that gives you just the quantity. And the definite integral gives you the change in quantity from one bound to the other. And just keep in mind what the units of your independent variable are, and the bounds of your integral are going to be in that unit. And this is the kind of topic that has infinitely many different kinds of contexts and situations, so they might not look exactly like the ones I've shown you here, but they all follow the same sort of theme, that when you start with a rate, then the integral of that rate will give you a quantity.